Okay. Is that working? At work right now, would binge it later, keep going. I mean, you shouldn't be at work and watch this. Okay. Yeah, hello everyone, and welcome to yet another live stream. Looking at Odin and building an HTTP server that is more or less a toy project to get a feeling for the language. Yesterday we looked at HTTP header map implementations and the performance, different performance characteristics of different approaches. So let's maybe make a quick recap. Open Excalibur. Okay, so we looked at three different implementations, and maybe let's look at the problem first. Well, 1 second. Pop out the chat. Good. So we had this problem where we want to parse the header, the HTTP header, and there are several header fields in there like connection, keep, alive, and yeah, I don't know, other things like host, localhost, for a whatever, and some other fields like whatever. What do we have? So we had fields that were common fields, and we had less common fields, but regardless of that, what we did is we generated messages based on common fields and less common fields. So we had, let's see, we had these common fields like, okay, host, connection, content type, and whatever, and we had less common fields, and we always included the common fields in the messages and took a random number of the less common fields. And then what we did is we took 3 implementations of a header map, 2 very basic ones and 1 with a hash map, with a hash. And we compared them, how fast we can insert and get from them. So we had a linked list approach, our linked list that was walking through the headers and looked at the header, connection, inserted it onto the head. So we had the first header, Then we looked at the second one. We set this to the next and this to the head, and added new headers as we go. So this is basically the representation of the header map with name and value, or key and value, as fields. The second approach was to have an array of a fixed size. So this is fixed. And just insert elements into the array, and when we try to get a value from the array, we just scan through the entire array and see if we can find the key. The third approach was to use a fixed size backing array we called buckets, and hash the key, mod the size, and then use this as an index into the array. And if if two keys collide, we look at the next element and the next element and the next element. And what we found is that the array-based approach is 50% faster than this linked list approach. So, which makes kind of sense. Although this is contiguous in space. But what we also found is that, so what we were actually measuring is inserting and getting all of the, so inserting all keys and values that are present in a message for several messages, and then getting the key out, getting the value out of the hash map. We did that for all keys in our message. And then we took the timing up front and the timing in the end, and then we subtract them. And we do that several times to get the minimum time, and then we compare those. And what we found is, with the hash map, this is actually the slowest, which is kind of surprising. So scanning through the entire linked list and scanning through the entire array, I mean, we don't scan through it if we find it early, which is a factor, is faster than just computing the hash and looking at the array and then comparing the key, comparing the keys. So there are several things why this might have been slow. So one is obviously the hash function. This takes time. Although it shouldn't take that much time, it takes some time. And especially if we do it over and over and over again, might be just faster scanning through the entire array. Also, if we do this test, this is all contiguous in the array, and this hash map, this might be sparse. Like, there could be an element here and there could be an element here, and there's nothing in between. So there might be some caching behavior that causes this, because this is all contiguous. This might have holes. This might be a factor. Also, what's pretty expensive is the modulo, probably. But these were the two factors I looked at after the stream, actually. So I went back to and poked around it a couple of minutes, maybe half an hour. And I found that so if we look at hash insert, I now have a constant bucket count. And this bucket count is a power of 2, which means that we can just mask the top bits off to get the index into the key. And I hope that the hash function is good enough to just allow that a power of 2 size, and spread it evenly, spread the keys evenly around the space. The bucket space. And what I did, I exchanged the XXH32 function for the XXH3 64 default function, which appeared to be faster. We would have to look at why, but this appeared to be faster. And then what I did is, in the get, I replaced the get for a get pre-computed, and I pre-computed all the hashes for the individual keys to index into the array. So if we look at hash get and get pre-computed, hash get pre-computed, then we provide a digest, which is pre-computed. We can use that digest to index the array based on the bucket count. And yeah, and then we just look at the field. If it's nil, okay, it's not in the hash map. Otherwise, we compare the keys. If the keys match, we return the value. And this turned out to be much faster. I mean, I think what we should do is look at the output assembly to be sure that nothing gets carved out. But yeah, I don't know. So what we can do is go back into hash and maybe build this again with O aggressive, and then execute it, and then look at the output. Oh, thank you for the follow. Is the Odin language new, or have I never heard of it before? Odin language is not new, but it's pretty small a language. So let's see. I don't know how old it exactly is. Let's see, Odin handmade network. I think it started here. So there were discussions about this starting in 2017. It was originally something that originated from this Handmade Hero project, and inspired Gingerbill to build his own language, I guess. And yeah, so far, I don't know how many people are working on it, but mainly it's been his personal project, I guess. Yeah, and it's basically inspired by Go, a little bit Python, but as a system language. Also Jai, Jonathan Blow's language. Systems language that is simple, has some nice features, and yeah, can target hardware. Is a simplicity, sort of programming, whatever. Okay. And what we see is if we look at the hashes. So we see the minimum time it took and the gigaheaders that we could parse per second, or insert and get per second. So this is 63 million headers with the linked list, 82 million with the array, and 84 million with the hash map. And before, the hash map was even slower than the linked list. But now we could get it down to somewhat similar of the array. And my theory is why the array performs so good is that these data maps are typically not that big. I mean, there are 12, 13, maybe 20 headers, but not more than that. Yeah. Typically no more than that. So what I want to do now is replace our linked list header map with the header map we have here, with the hash, the HTTP header map hash that we tested and found to be faster. But only if we have pre-computed the hash. If we don't use pre-computed hashes, we can look at that as well. If we say, okay, hash get, and it's only the field key, compile it again. Then we'll see something similar, obviously, for the linked list and the array header map. So again, 63.4 gigaheaders, 82 for the array. And for the hash map, we now get 70. So huge penalty computing the hashes. Yeah. Also, something I want to look at is, we could take a look at we could take a look at the output assembly and what's actually happening, and why this is so slow. But I probably don't want to do this at the moment. So what I want to do is put this hash map into that we tested is a little bit faster if we use pre-computed headers. I mean it's 50% faster than the linked list that we currently use, or more or less 50%. I mean, it's not 50% really, right? It's more like 30%. Yeah. So, okay. So let's get So this makes a huge difference, right? At this point, it's just better to have an array if we don't pre-compute the hashes. It's cheaper to just compare all the memory. And this might be to something being odd in our test setup, but I don't think so. This might be due to the memory layout, I don't know. These being all contiguous, there might be something. Okay, so in our http.odin, if we look at handle connection, no, it's handle, yeah, it's http parse, right? If we look at http parse, here we try to, yeah, and parse header. Here we use the connection arena to allocate a new entry into the header map. Okay, and then we set the, we could just do here connection.request.header map, no, entry.next, something like this. But whatever, we delete this anyway. So at this point we just assume to have something ready, and we just want to, so we have the hash map, which is set up. Header map, or like header map insert, and then we use the connection dot header map. I don't know what the name was. Yeah, it's header map, connection dot request dot header map. Okay, so we want to do this, and we want to insert the name and the value. I think that's it. And when we handle the request, also this here cannot be done. Here we say header map insert, and then it's connection, it's response dot header map. There's probably a reference to it also here. And we insert the connection literal transmute u8. I mean, I don't want to do this over and over again. Let's go into literals and say connection literal is equal to transmute u8 string transmute u8. Let's do that for these as well. So let's recode a macro. Let's f the equal wi transmute u8 string, go down, go to the beginning, q. Good. Also here, okay, here apparently doesn't work. Okay, transmute u8 string. Good. So obviously at let's move hash.odin. Well, let's nvim hash.odin. Let's move it. Let's comment out this main test thing. I'm not sure how you have multiple mains in an Odin program and make it output multiple binaries for that, but whatever. Probably you can't. And in HTTP, no. Where was it? It was in, hey, 1 second. In HTTP, what did I want to do? So I want to look at the errors, right? So cd .odin build onon debug. You opened my horizons, but I have to go now. Thanks for everything. That's nice to hear. Have a nice day. Okay, so undeclared name. HTTP, so header map insert. Let's have, should we have a separate file for this? So I don't want this to be in a separate file. Can we somehow keep this in here? Yeah, I don't know. So maybe we just have an HTTP header map, which is a struct. And this is the bucket count, and we just call it a day with 128. And this has buckets with this is an array of an HTTP header entry, or I think they call it header field, but let's call it entry, whatever. We might want to have we might want to have the key directly stored in the header. This might be something we want to do, but I'm not sure. Okay. But again, we don't really have a lot of headers, right? So this will be kind of minor. A kind of minor thing to do, right? Okay, good. So we have a length, which is a U32. Probably that's it. Get value, header map get, header map get pre-computed. So this is exactly what we had in our hash. And header map insert. This is a proc which can return an error. And this returns a result U8 or an error bool and an error bool. Okay, this takes the header map, which is an HTTP header map. And we insert a name and a value. Okay, so we need import core hash xx hash. We remove this here. First and foremost, we want to get the key index, which is the xx hash dot xxh3 64 default. And we say for index 0 index is less than the length of the header. So let's using header map, the length of the buckets, index plus equals 1. So this is the digest. Say key index is equal to digest plus the index, and then end it together with a bucket count minus 1. And we have a field which is equal to the bucket Hey. Yeah, did you looked at the benchmarking for that's nice. I also took a look at it yesterday afternoon, and I found that by pre-computing the hashes, it was much faster. Yep. So buckets, I will take a look at it. Key index. So field.name is equal, or field.name is name, field.value. Turns out hash map is pre-constant time on insert and get. Linked list and array are basically free on insert. Yes. Think pointer, set, and index increment. Yes. But obviously we need to run our hash function, map it into our range, and set get from memory. Yeah. So I thought the big killer is hash map occupancy should be out in hindsight. Yeah. Yeah, it's also how yeah. That's true, but if if you run a lot of, for me at least, this test where you hammer the hash map and the hash function all the time, and it also comes down to the machine you run it on. but with a naive linear probe, we get massive slowdown. Yeah. For me, using a pre-computed hash speeded this thing up by quite a bit. Implemented a Fibonacci hash to map the hash value better, and that helps. That's cool. Very nice. Maybe I take a look at it later. It's not as good as a naive array. Can't beat the array. Yes, I will take a look at it. Yeah, it may be. It may be. Very nice. Have a nice day. Good luck for work. Okay, so what did I want to do? So if the field is equal to nil, no, it's not equal to nil. Oh my goodness. Okay, key index. Now we have to look at, so if the field dot name, how did I do it in the hash map? Do I have an error there? Hash insert dot key. I checked the key. Okay, good. If it's not equal to nil, now if it's equal to nil, we just set this thing and return. Here we set the error equal to true, return. I believe that's it. Maybe we also don't want to insert duplicates. So if memory compare maybe we just do it, I don't know. So I'll make it to do in here. What about duplicates? So same thing here. Digest. No, that's get pre-computed. It's using header map. digest is equal to xx hash SSH64 default name. Let's call it error for IDX 0 IDX is less than length of the buckets IDX plus equals 1. The key index is equal to the digest plus the IDX, and together with a bucket count -1. If the field, so let's say field is equal to buckets key index, if the field dot name is equal to nil, we say error is equal to true and return. Otherwise, we have to memory compare the keys. So name, field.name, and name. And if that is true, we set field.value equal to, no. The value is equal to field.value or result, and error is equal to false, no, return. If we iterated through this entire thing and didn't found an empty slot, we set the error to true and return. Also header map reset. Header map we iterate through all the keys, bucket in buckets, bucket.name is equal to nil. And also an init method. Header map init. Takes an arena. And it makes an HTTP header entry with bucket count and the arena. This is the header map dot buckets, header map dot count equals 0, and reset count is equal to 0 using header map. Delete this. So the get pre-computed is basically the same thing. Header map. We already have the digest U64. I mean, this is kind of the index. So for IDX 0, IDX plus equal, IDX less than length buckets, IDX plus equals 1. The key index is equal to the digest plus the index and together with the bucket count -1. The field is equal to bucket and key IDX. If the field dot name is equal to nil, error is true, return. If memory compare the field.name and the name, then we set the result equal to field.value and return. If we don't find anything, we set the error to true and return. So these are all the methods. Okay. Let's see what happens. Has no head in 31. This is in connection. 31. Header map. So we just call header map reset on the con.request.header map. And header map reset on response.header map. On the pool init, we call base arena we call header map init with the con.request.header map and the base arena and the response.header map. Yeah. Okay, so the next thing, let's see. Count is equal to 0, http.odin. http 94, count is equal to 0. HTTP header map, it has a length. Okay, that's great, length. And 107. This also has to compute the hash for the name. Can I call non-procedure? Okay, so that doesn't work anymore. So now I remember why I called it count. Because length is reserved. Let's call it count. Length is 0, count is 0, count is 0. (148) error is equal to true. Okay, 110. Always forget that this is a U32. Now this is a U64. Same thing here, U64. Same thing here. Oops. bucket. It's buckets. XXH3 result is undeclared 161. Okay, it's value. Okay, and we're getting there. It's in 270. Okay, so here we also have to do something. We say, so we don't have to transmute, right? So we can just say header. So it's connection, no, it's response. Response.header map and header map insert the content length literal. Here we can also do an insert pre-computed. Let's do that, pre-computed. Content length literal, 0 literal. Or no, what did we want to do? So this is the content length and content length this. So this makes it a lot nicer. Pre-computed. And we want to insert the close literal and then some connection hash content length hash. Let's see. Okay, let's see. We also want to insert something else. Header map insert pre-computed. Let's for now just let's just assert not error. Handle these errors. I mean, these should not happen. These should not happen. We insert this and this into the response with the content length literal, the 0 literal, and the content length hash. So we don't need this anymore. We probably consider reporting back that we should close the connection. I don't know what this to do says. Should be probably here. So this should no longer be this. Also that we have to transmute this is not so nice. Literals. Let's make it a U8 by inserting transmute U8 string here, and recording a macro. Look at this. Look at this. Go to the beginning. Find the comma. Insert. Escape. Down. Stop recording. No comma here. Okay. Look up status code. It should return this. Okay. So the content length hash, all these hashes now don't exist. Let's just put them in here. Now here a pound define would be handy here, right? But we don't have that. So 0 hash is something. We need a content length hash. We don't need a 0 hash. We need a connection hash. We need a host hash. Let's just make them. We might need a host hash. Something else? I mean, we could look at these headers here and just copy them. Yeah, we could just copy those and go to literals and paste them in here. Now, can we do this with a macro? I think we can. Okay, let's look at this. We do a macro. Let's look at this. Macro. Find quote. No. Again. Delete find quote. And then one word, delete to comma, delete to comma, going back, make it uppercase, insert literal, colon, X, go to the end of the line, delete, delete, go down. Do you see that? Okay, I screwed up. Okay, they were not all the same, because there were commas in here. Okay, that worked, that didn't work. It was close. Let's see. And literal, also not correct. I wanted to name this literal hash. not a comma. Okay, let's see. Content length hash. It's content. Now we don't know which one. Length. Content type. Okay, so why do we have 2 accept hashes, 3 accept hashes? So this is accept encoding. Our macro was not good. Example, accept language. Good that we have these comments here. And this is cache. Let's see. This is cache control. Cache control. It would be nice if we could have some metaprogramming for this, but I don't know. I don't think we can do that in Odin. Let's see. In literals. Okay, let's see, what is it? So this is an array of arrays, right? Is it like this? Okay, that's crazy. Uncreate name, header, map, insert, pre-computed. And we should have that. Header, map, insert. Where's the definition? Header, map, insert. And let's also have a header, map, insert, pre-computed. And this also takes a digest U64. Delete that. I think that is it. Okay, so in 324, write response, header entry. Yeah, so this is kind of this is somehow where the hash map falls apart, because we have to iterate through all of these, which is not so great. So bucket in buckets. If bucket dot name is equal, not equal to nil, we want to write bucket dot name, bucket dot value, uncreate name bucket. Are you kidding me? I have bucket declared, right? I have the bucket declared for bucket and buckets. Still complain. 3, 2, 4. Undeclared name. Oh, buckets. It's header response dot header map dot buckets. 368. We should set up NeoVim in a way so that. Okay, so maybe we should have. So in connection reset. This does this. Let's make a connection reset with offset. Offset U32 and set this to offset and then, oh no, connection reset. Writer offset, parser offset. HTTP Odin. Okay, so we want in here connection reset with offset the connection, and then with parser.offset minus parser.message length. At this point, just assert that the message length is greater than the parser offset. Remove this to do, so we don't have to do all of this, which makes it a little bit cleaner. Three, 6, 8. It shouldn't be there anymore. So content length sure get value. Okay, so this is header map. Let's just declare error here as a bool. Error. Oh no, that won't work. CL found. Not found. CL error. This is the connection request header map, the content length literal with a content length hash. So header map get pre-computed. I think this is the only place where we get right. So if CL error so if there's no content length, okay, that builds. Let's see if it still works. Okay, that seems to work. Let's go to Safari. Let's open a netcat localhost 8080 and localhost 8080 index.html. Good. That works. Okay, we swapped that. I want to make the assets also. So let's have an asset count. Let's have, I don't know, 128 assets. I don't know. Maybe that's too little. So asset store init. This now becomes, so an asset. And let's have a count. And so U32 and assets, which is an asset array. So in here, we want to say, okay, using asset store assets is equal to make asset count and arena. And then we have an insert asset store insert, which is a proc. That gets the asset store. And an asset name U8 and a value U8. An asset store get. No. This can return results error. Okay, when we init this should be that. Okay, insert. What does insert do? We just look at the count, and if the count, so this can also return error. If the count is equal to length of assets, probably has to be converted to U32. Error is equal to true and return. If there is space left, we just iterate through, no, we say that asset store, now let's just use using asset store. We set the assets at the count equal to a new asset with name and value. And then we say count plus equals 1 and return. Asset store get, also very simple. We just iterate through the entire array. Asset in assets. If memory compare asset dot name with name. We set the value, the result equal to asset dot content. Okay, let's name this content. And return. Otherwise, we set the error to true and return. So asset store base pointer so we read into this slices pointer. What do we do here? Can I read from asset file? Where do we create the new one? Make, oh here, make, no. Okay, I don't really get where we do this, so let's just say name. Then we make it with a name length. We copy it over. Into the name. We set the content equal to the base pointer. Yep. His name is content base pointer. Content base pointer. No, this could be our content directly. And then we do asset store insert with the asset store and the name and the content. Asset store item. Oh, here we do that. Don't need to do that anymore. Also, when we insert, we need to, yeah, we did increment the count. Did we do it in the hash map as well? Header map get, header map insert. No, we didn't. So count plus equals 1. Count plus equals 1. So asset store dot head. Oh, there was a get method. And HTTP. Let's see if this works. About. Good. See if it also works in curl -v localhost 8080 not found. Good. It just sent an OK, so that's wrong. Should be a not found. So asset store get. Where do we asset store get? Asset not found. Asset error. So if asset error, if not asset error. Let's see. Format.println found request.uri1 ongoing. Content asset error. Asset error is false, so asset store get. Is there a bug in our memory compare? The content is empty. So let's see, LLDB HTTP. Let's break here 37. Break assets.odin 37. Run. Okay, again it wants to know my password. Please. Okay, so process launched. Asset.name. What is it? What's available? Asset. Oh, this is completely wrong. No, it's not. It's index.html. Print the name. Length 0. Okay, our memory compare somehow screws something up. Memory compare. Okay, let's rerun it. Let's go here. Let's step into this. What doesn't work? Print A. Print B. Return false. It's completely broken. What is it? Why is it broken? Let's do it again. Break at 38. PA, PB, return false. Asset.name. Oh, they've both length 0. Because they've both length 0. That's great. So if asset.name is not equal to nil, and this. Not found. Let's go here. Good. Okay. Okay, now we printed something. What did we print? Here. Good. Index.html. Hello, sailor. Good. I'm gonna go pee and make myself a tea, and then I'm gonna be right back. Okay, so we need to handle some errors, probably. So let's just say this, assert not error. So in our HTTP parse, If we have a parser state error, we just don't report anything back, which is bad. We should report a reason. So, I mean, what we could do is just say everything is a bad, so get pre-computed. Parse. What keyword do you use? I use a glove 80. Second. Yeah. Why do you want to know? Oh. Parse header. Where is it? 1 second. Yeah, so let's look at it. Full screen. Glove 80. I wanted something split and concave. Concave. It sounds nice. I just joined and noticed how you use NewVim, so I was wondering if you're like. Yeah, actually, I got a little bit inspired, just a little bit. So the reason I don't have a kinesis is mainly because in Europe, this thing costs, I don't know, 500 euros or something. And that was a little bit too much for me. Yeah, I think in the US it's not that bad, but with value added taxes and stuff, it's pretty bad. Yeah. Okay, so I don't handle this error here. So if error parser state error. I wonder if Odin can report these things, like Odin type checks, Odin check, Odin check help, check for unused declarations, unused imports, unused procedures, unused checks for the user using state as a statement. Using is considered bad practice outside of immediate refactoring. Shattering. Errors are missing trailing commas. Deprecated syntax. Is there something like, can it check on show unused, show unused, show timings, show no warnings. I don't know. Oh, thank you. That's kind of stupid. Classic. Okay, so when I send too many headers, I should now get an error as well. But I don't report the error, so we switch on the parser.state, I guess. Parser.parserState, yes. And when we have an error, we just close the connection, which is not what we should do. But rather we should write a response with a connection or write error response we could set the response so that we could set the response. I'm unsure where we do this, so should we do this in parser.parsers here? So we could say, okay, connection.response dot header map or dot stat connection.response dot status code, and then we HTTP status code that request. Then we set this to no, say header map insert pre-computed connection literal with the closed literal and the connection hash. And then write response like this, and then dot close. No. So in our HTTP Darwin, what do we do if we get a close? We reset the connection, and then we release it in the pool. So I don't know, that I want to figure out where we close stuff. Where should we close our connection? Because I feel like we should close it in the platform specific code. Okay, write response and then close. Is that about right? Odin build onon debug. Can assign value in 375. Net dot close connection dot client socket. So when I send nonsense to this, oh, it just keeps it alive. What could I do to set up the parser? Yeah, I would have to write a script here, right? To test this. Yeah, we would have to set up a testing suite, which is something I should put on the list as well. We should have some proper tests in place to test this server. Okay, so I believe there are error codes for too many headers. RC HTTP. Let's see. Let's Google it. And 429. No. Where were the errors here? So we've not found method not allowed, not acceptable, length required, request URI too long. So we have all these things. Request entity too large. That's also something that we have not yet accounted for. So if we search for parse HTTP parse, we try to read into this buffer. So if the length of this buffer here is not sufficient anymore, so let's say parser.offset, if parser.offset is equal to the length of parser.buffer -1. So this thing gets too large. We also want to do this. Probably want a method for this, but we say, okay, response.status code is equal to, request entity too large. Is that the right one? The server is refusing to process a request because the request entity is larger than a server is willing to be able to process. Server may close a connection. Status code is, let's add that to the status codes. 413, request entity too large. Status code. Oh. Let's paste that. So that's a 4 and a 13. 2, 3. So The way we did that is by saying the first 8 bits represent what the category is, and the second, the following 8 bits represent what the specific error or whatever is. So entity too large. And then we look it up in our literals and say, okay, this is request entity too large. So that won't work, obviously, because we don't have these here in between. It has to be contiguous. We have it up until not found. So what if, 1 second, can you bring the HTTP error codes starting from 405 into the following format? Transmute 8 string, and 405 is what again? It's method not allowed. 405 method not allowed. Comma transmute U8 string 406. Let's copy this. Payload to large. I believe this is not quite the same. So we have those now. Payload to large, but this says, so I use the chatbot. Length required, is that the same? Yes, length required. Precondition failed. Payload too large. Says request entity too large. $45. Now dot close in HTTP 349. So this is dot request entity too large, and response, so header map insert pre-computed response dot header map. Then we insert connection close, a connection literal with connection close, and the connection hash. Good. And this should never fail. Assert not error. Then we want to write the response with the writer. We also forgot that, right? No. Write the response. So at this point we probably want a method for this, but a function. But whatever. Write response with a connection. Assert not error. Also, this can fail. So this can also fail. I wonder if we should, so we have a fixed buffer size for the response, which is whatever, 2 megabytes or something. So if we look at this, so the response buffer is 2 megabytes. In our asset, we should probably check if our assets are larger than 2 megabytes. So when we write a string, write memory or a string, we just, oh, we have error for this as well. But we never check that. So in write response, we never really check for errors here. You could say error is equal to this, error is equal to this, right? But these should not fail. Just make it to do, please. That's the easiest thing, right? Just make it to do, call it a day. Great. Okay, so if we build this, it doesn't work, so unclick name connection close. Yeah, that's true. It's close literal. Length of parser to buffer, if this is 0, it wraps around. That would be bad. So, I mean, the parser buffer should never be 0 length, right? Curl v localhost 8080 not found index.html. Got it. Okay. So one thing I want to do is maybe introduce a database, but maybe not. I'm not sure about that. But what I want to do is introduce OpenSSL and see how it goes with Odin. So the Odin, they had an example implementation, Odin HTTP. And I'm not sure oh, they have a custom allocator. Just parents. I have a block allocator. Okay. OpenSSL. Yeah, well. Should be looking at this. Because I believe it's not built into the package system. So probably we have to write bindings for this. When shared, config OpenSSL shared. So I don't know how you do foreign stuff. Let's see. So we have the overview page. On Mac OS, I am foreign import. Okay, foreign import. Mac OS OpenSSL. OpenSSL GitHub. I don't know if I have these headers, right? So demos. Let's see. Encrypt bio. Peaky Mac. SSL echo. You have these files, okay. Main.c. So this is OpenSSL SSL. Let's see if we can import this in C. So main.c in main. Void. Pound include OpenSSL SSL.h. Let's see if it's already installed. So clang main.c. Nope, it's not installed. So let's go here. Can we build this? Let's see. Should we build this? So paste this in here. Build and install Unix-like platforms. Configure. Let's see. clone this thing. Okay, go into OpenSSL. And do we have a makefile? No. Install Markdown. Building OpenSSL. So let's look at their configure script. Oh no. Let's not look at their configure script. Let's try to just run configure. And now there is a makefile. So make -j8. Hopefully this works. Let's hope for the best. Okay, so make install. Sudo make install. Okay. That's quite something. Hopefully this just works. I wouldn't be surprised if it doesn't. How many Perl scripts is it executing? I mean, this is ridiculous. Okay, so let's see if we now have OpenSSL, clang main.c, link SSL, found not found. Find /user include. Is there user lib exec lib? Where are the includes? User share open SSH. Where did it install all this stuff? Doc. util. Use a local share. Doc, use a local share. Man. Okay. macOS include paths. Okay, I don't know why. Clang dash. So it doesn't find the header bin. This SSH open SSL. So that's the executable. I want the libraries. Open SSL help. That's no help. Open SSL help. Oof. That's not really helpful. So where do I specify clang-c clang main.c lcrypto xcron show SDK path? It's not really helpful. macOS include path. And then here, user include. And there's no OpenSSL. Build OpenSSL from source Mac OS. Okay, we should have configured it differently, I guess. Open. So let's try to configure this again with a prefix user local and open SSL the user local open SSL. So make -j8 again. It's maybe nothing I should do on stream. Trying to figure out how we get this to work. Good. Okay, so make install. Sudo make install. Good. Okay, let's see. Let's maybe, I don't know, see personal HTTP. So nvim main.c clang dash main.c link SSL. Nope. Okay, let's see. So where are the headers? User local, OpenSSL. Now user local lib include OpenSSL c. There are the headers cat SSL/h. Good. So these exist. If we do now clang main.c and link with user where was it? I had it open. User local shit. Build and install Unix like. So user was user local include OpenSSL LSSL. LSSL L crypto doesn't like it. Clang add to include. Oh, it is it's I right? Okay, so this now works. Question is, can we library SSL not found? So let's make it verbose. So user local bin OpenSSL, no. User local include. And we want to link against it, but okay, so I -l user local OpenSSL. Bin. User local include SSLH. It's not able to link against this. Library SSL and font. So, okay, this is... I would have to figure out how you install this correctly. I think I will end the stream with that and figure it out off stream, because this is kind of annoying to get it right on macOS. Yeah, I hope you enjoyed the stream, and I wish you a nice day.